Section 10.1 on lines. First, we're going to look at the inclination of a line, which is just the angle that is formed from the x-axis to a line. And it's always an acute angle. And we're going to be using radians and degrees to measure the inclination. So the formula for inclination has a relationship with slope in that m equals tangent theta. So I can use this formula to solve for the inclination, which is theta, or I can also solve for the slope, m. Next is the angle between two lines. So two lines, as long as they're not perpendicular, have an acute angle between them, and the formula that we're going to use to find that angle is tangent theta equals the absolute value of m2 minus m1 over 1 plus m1 times m2. The distance between a point and line. So as long as you have a point, an ordered pair somewhere out in space, and the equation of a line where everything is on one side and set equal to 0, you can use this distance formula to find the length between the line and the point. So the formula is distance equals the absolute value of a times x1 plus b times y1 plus c all over the square root of a squared plus b squared. Now a, b, and c are the coefficients from the equation of the line. x1, y1 are the ordered pair. So example 1 says to find the slope of the line with the given inclination. So we're going to use the formula m equals tangent theta, and we're going to substitute theta 3 pi over 4. So m equals tangent of 3 pi over 4. The one thing you want to make sure with these problems is that you're in the correct mode. Since we're plugging in an angle, and the angle that they gave us is in radians, you need to be in radian mode. So all you have to do is type tangent of 3 pi over 4 in your calculator, and you'll get that m equals -1. So what this means is there's a line that makes an angle with the x-axis that's equal to 3 pi over 4, and the slope of that line is -1. Okay, number 2 says to find the inclination of a line in radians and degrees that goes through the points 6, 1 and 10, 8. So since I have 2 points floating out in space, first I need to find the slope of the line that would go between these 2 points. So remember that slope equals y2 minus y1 over x2 minus x1. So I'm going to plug in my ordered pairs. 8 minus 1 over 10 minus 6. So this means that my slope is 7 over 4. So I'm going to plug in my slope into the same formula as the last problem, m equals tangent theta. And this time I'm plugging in 7 over 4 for m. And I want to solve for theta. So since 7 over 4 equals tangent of theta, to get rid of the tangent, we have to do the inverse tangent. So inverse tangent of 7 over 4 equals theta. So it doesn't matter what mode you're in because we're going to get our answer in radians and degrees. So if you go ahead and type inverse tangent of 7 over 4, since the last problem we were in radian mode, the first answer that we're going to get is in radians. So this will be 1.05 radians. Then you just need to change the mode in your calculator to degrees and go back and hit enter and recalculate inverse tangent of 7 over 4. And you'll get that in degrees it's 60.26 degrees. Number 3 wants us to find the inclination again. This time it gives us an equation of a line. So we still need the slope to find inclination. So with an equation of a line, the trick would be just to get y by itself If the equation is in y equals mx plus b form, which is slope-intercept form, then I'll know the slope of the line. So this means I need to move the 6x and the 8 to the other side. So negative 2y equals negative 6x minus 8. Then I'm going to divide everything by negative 2. So then y will equal 3x plus 4. So then the slope of the line is m equals 3. Now I can plug into the formula m equals tangent theta, so 3 equals tangent theta. And I'll take the inverse tangent again to get theta by itself. So then I need my two answers, a radian and a degree. So I get that theta will equal 71.57 degrees and 1.25 radians. Example number 4 says to find the angle between the lines and in radians and degrees. So to do this, we need the slope of these two lines. So I'm going to get y by itself for each one to identify the slope. So the first equation will be y equals negative 3x plus 3, and the slope of that line is negative 3. The second equation, when I get y by itself, will equal x minus 2. So the slope of this one is 1. So now I'm going to use the formula tangent theta equals m2 minus m1 over 1 plus m1 times m2, and then we take the absolute value of all of that. So when I plug in the slopes, I'm going to get 1 minus a negative 3 over 1 plus 1 times negative 3. So then on the top, I'm going to get a 4. On the bottom, I'm going to get a negative 2. So 4 divided by negative 2 is negative 2. And then I take the absolute value and I'll get a positive 2. So tangent theta equals 2. Then I'll take the inverse tangent to get theta by itself. And again, I need two answers, radians and degrees. So I get 1.11 radians and 63.43 degrees. Number 5 wants us to find the distance between the point and a line. So we have the point negative 2, 1, and the line x minus y equals 2. So to work this problem, I have the point, and I don't need to do anything to that, but I need to rearrange the equation of the line to move everything to one side. So that's going to be x minus y minus 2 equals 0. So then we need the formula for distance, which is the absolute value of ax1 plus by1 plus c all over the square root of a squared plus b squared. So a, b, and c are from the equation of the line. It's ax plus by plus c equals 0. And x1, y1 is the ordered pair. So on the top, this will be the absolute value of 1 times negative 2, so that's the number in front of x, times the x coordinate, plus negative 1 times 1, the number in front of y, times the y coordinate, plus c, which is negative 2 from the equation, all over the square root of a squared plus b squared, so that's the square root of the number in front of x, which is 1 squared, plus the number in front of y, which is negative 1 squared. So on the top, this is going to be the absolute value of negative 5 over the square root of 2. So this would be the distance equals 5 over the square root of 2. I don't need to rationalize the square root. Since I'm just finding the distance between the point and the line, I'm just going to type this in my calculator. So 5 divided by the square root of 2 is approximately 3.54 units. And remember that distance measures an amount of space between something, and so it could be inches or meters or centimeters. Since we don't know what that is, we put units. It's not a radian or a degree. Okay, number 6 wants us to find the distance between the parallel lines. So this is going to be the same as example 5. I need an equation of one line and a point on the other, just to find the distance between the two. So I'm going to take the first equation, 2x plus y equals 1, and I'm going to move everything to one side. 2x plus y minus 1 equals 0. Then I want a point that's on the second line, 2x plus y equals 5. So it can be any point on this line. So to make it simple, I'm going to plug in 0 for x and solve for y. 2 times 0 plus something has to equal 5. Well, 2 times 0 is 0, so 0 plus y equals 5, then y has to equal 5. I could have picked any number I wanted to plug in for x and then solve for y. To make it easy, I picked 0. So now we're going to use the same formula as example 5. Again, a, b, and c are from the equation of the line. Ax plus by plus c equals 0. x1, y1 is the ordered pair. So this is going to be the absolute value of 2 times 0 plus 1 times 5 minus 1 all over the square root of 2 squared plus 1 squared. So this is going to be the absolute value of 4 over the square root of 5, or just 4 over the square root of 5. So when I type this into my calculator, this is approximately 1.79 units.